In this video, what we're going to do is we're going to explore some of the properties of different types of polygons and then how to find the value of missing angles in a polygon. And just to start, really all that a polygon is it is a shape that is made up of straight lines, and it is completely enclosed. All right, so it's completely enclosed. So that means there's no openings. The straight lines part means that there's no curves and stuff like that. And so the most basic polygons that you know, of course, are triangles and different types of quadrilaterals. And then we can go up from there and have, pentagons and hexagons and heptagons and octagons and so on and so on. But we're going to focus mainly on triangles and quadrilaterals. Now the first thing that we're going to need to be able to do is find out, so we can build equations later on, how many degrees are there in each type of polygon. So what I'm going to do is I'm going to build a quick example of a triangle. So I'm going to just build a triangle and then another one and another one. So here's my triangle, and the quick thing what we can do is we can quickly measure all of the different angles here. So I'm just going to measure the angle and get 63.28 for angle B, and for angle A it is 69.64, and for angle C it is 47.08. Now that's fine, but what's more useful for us is to actually add those together. So I can actually do that by calculating, but instead of typing in the numbers, I'm actually just going to click on the value. So I want to measure angle B plus angle C plus angle A. And if I do that, I get a sum total of 180 degrees. And the cool thing is, no matter how I change this this triangle, you'll see that while the values of each individual angle change, the sum still stays to be 180. So because of this, we can now conclude that the sum of the angles in a triangle is always going to be 180 degrees. So triangles are always going to be 180 degrees. And this is sort of our key understanding for looking at other types of polygons. So I'm just going to build a quick quadrilateral here. So quadrilaterals, quad coming from the word for four, 1, 2, 3, and 4. And it doesn't really matter how you build that quadrilateral. They all have four sides, and as a matter of fact, they all add up to the same if you measure the angles. Now, instead of doing the same thing and measuring them all and adding them together, we're going to look at a slightly different way of doing this. If I draw a line connecting one vertex to the diagonal vertex, you can actually see that I've divided that quadrilateral into two different triangles. So I have one triangle here, and I have a second triangle here. So to find the sum of the angles in a quadrilateral, it's really 2 times 180 degrees, which gives me 360. And I can do the same thing with a pentagon, where I can go 1, 2, 3, 4, 5. So a pentagon has 5 sides. And I'll do the same thing. Instead of measuring them all, I'll just divide it into some triangles. So I'll pick this vertex here and draw one diagonal, and then I'll draw a second diagonal. And now that I've divided my shape into triangles, you can see that there are 1, 2, 3 triangles. So no surprise here that the total of all the angles on the inside is 3 times 180, which is equal to 540 degrees. And so you can continue using this pattern to find the sum of the angles for any polygon. There's a faster way we can do this though. We can actually make an equation out of this. So to do this, we'll say that the sum of the angles is equal to n being the number of sides of your polygon, minus 2 times 180 degrees. And the key understanding here really is that if n is the number of sides, by subtracting 2, we get the number of triangles. And you can see that over here. Our three-sided shape only has one triangle in it. Our four-sided shape has 4 minus 2, or 2 triangles in it. And our five-sided shape has 5 minus 2, or 1, 2, 3 triangles in it. So this formula here we can use for helping us find the sum of the angles in any given polygon. What we're going to do in the second part of this tutorial is we're going to look at combining what we know about algebra with what we know about the sum of the angles in a polygon to help us find the value of some missing angles. So in this case here we have a triangle ABC, and we're told that the measure of angle B is 38 degrees, and that angle A is equal to 3n plus 2, and angle C is equal to 5n minus 4. So really what we have here is we have a situation where angle A plus angle B plus angle C would equal 180 degrees because it's a triangle and they always equal 180 degrees. So now I'm going to substitute in what I know. I know that angle A is 3n plus 2, angle B is 38, and angle C is 5n minus 4. And that all equals 180 degrees. So the first thing I do anytime I solve equations is I look to simplify, and so 3n and 5n is 8n. And I've got 2 and 38 and minus 4. So 2 plus 38 is 40, minus 4 is 36, plus 36 equals 180. So now I'll subtract 36 from both sides, minus 36 minus 36. 8n equals 144, and then I'll divide by 8 and divide by 8. And if I remember correctly here, n equals 14 divided by 8 equals 1, 6, 18. So n is 18 degrees. Now just like the work we did with angles, we're not done here. We have to now use this value to find the value of the missing angles. So let's substitute this back in. 3 times 18 plus 2. So 3 times 18 is, I believe, 54 plus 2 equals 56 degrees. And over here, 5 times 18 minus 4. 5 times 18 is 90 minus 4. And 90 minus 4 is 86 degrees. So I have 38 degrees, 86 degrees, and 56 degrees. And if I wanted to do a quick check of this, really all I have to do is add those numbers together. 38 plus 56 plus 86. And if I've done that correctly, 30, 50, and 80 is 160 plus 8 plus 6 plus 6 equals 180. So in total, I have 180 degrees, which is in fact what I should have. So this is how we can kind of, continue making use of algebra and our knowledge about geometric figures to find the value of missing angles.